Okay, welcome back everybody. In this video tutorial, we're going to be taking a look at the problem 8.2 Automata Design Challenge, but this time we're going to switch a couple things up and we're going to make this a little bit more advanced. All right, so last time we did this, we were doing all just with the very basic stuff coming out of the box kit. This time around, we're actually going to switch some things up, some things that we have noticed, maybe to make things a little bit well, it's just going to be different. All right, let's just put it that way. All right, so last time we were using an actual square dowel rod for our axle, and we had to go out there and create a hole, and the that square dowel is going to be able to spin in that hole, and it had the shaft collars on the end. But here's the thing: if you're using a square dowel for your axle inside of a hole, it's going to make a lot of noise, and it's going to be almost like fingers across the chalkboard, and that's never a very pleasant sound. What you might want to do is something that I know some other master teachers or other IED teachers that do it is instead of using that square dowel for the axle, instead go out there and replace it with a 1/4 inch round dowel. Now, just letting you know, that does not come with the PLTW box kit. That's something you'd have to go out and purchase on your own. All right. The other thing is instead of using those very small 0.115 diameter round dowels for the follow rods on top, instead use the 1/4 inch square dowel that comes with it. So if that is the case, then we're going to have to go out there and create some sort of a bushing that is going to go into the top of the top part or the top piece of the box to allow those square dowels or follow rods to be able to move up and down. So with that being said, let's go ahead and let's get started. So there are going to be some new parts that you're going to have to go out there and create, all right? And one is going to be the axle, all right? So currently right now, our axle that we were talking about last time is going to look like this, okay? It's a square dowel. All right, that is not going to fly in this case. All right, so we're actually going to create a new axle. All right, so a couple things we're going to have to keep in mind is we are going to have a shaft collar. Okay, that's going to be on both sides of this, but this time the shaft collars, I don't know. Let's do something a little bit different. Let's make those shaft collars out of 3/16 plywood. All right, maybe you got a laser cutter on hand, and maybe you can put some plywood in it and cut that out. All right, so we're going to have to go out there and create those shaft collars. So I'm going to go ahead and actually create the shaft collars first, okay, or at least show you what those are going to look like. And they would look a lot like this. All right, so you can come out here and take a look at the sketch on this one. Looks like I created an outside diameter in this case, looks like 0.875. The inside diameter is 1/4, and that's going to allow the 1/4 inch dowel rod that's round this time to go through it. And like I said before, the extrusion on that one, okay, would be a distance of 3/16, and then I just came up here and made that wood birch. All right, that's all that shaft collar is going to be. All right, so this time we're going to have to remember that calculation of 3/16. And this time I want a true crank handle. All right, so I'm going to go out here and take a look. Here's just one that I put together. If I come out here and take a look at the sketch on this one, we're going to be seeing that these have a diameter of 0.25. Okay, we're going to use the actual diameter 0.25 round dowel as the what we're actually going to use, obviously, for the axle. And then in this case, it's going to be the actual little peg that's going to go into the end. That's actually going to be part of the handle. I don't know. What did I make this? Center point to center point, 1.3-ish, it looks like. Let's see. The outsides on this, almost, 1/2 inch diameter, and then this one, roughly 0.4 something on a diameter. Doesn't matter. I think I just eyeballed all this. Just know when I went to extrude that was an extrusion of 3/16 in this case. Put that in as wood birch, okay, and I went out there and I just saved that IPT. All right, so what this means for us is that we're going to have a shaft collar on both sides of this, okay, and we're going to have that crank handle, okay, on the other side of the shaft collar. All right, so we have to do a little bit of math here. All right, so we're going to come up here and measure this. Okay, we know that this distance is 5 inches. Okay, we can go ahead and pull up the calculator and say, hey, what's this going to be? So we're going to say, we're going to add that 0.1875 to it, another 0.1875 to it, and another 0.1875 to it. And we know that our axle has to be 5.5625. All right, so with that in mind, I'm just writing that down because I'm going to forget it. All right. So what that means for us is we have to go out there and create a new axle. So I'm going to come up here, go to my standard inch IPT and say create, start a 2D sketch, go out there, work on a work plane, go out there, draw your circle starting from the origin, and go ahead and, and we're going to dimension that to be 0.25 for my diameter. I'm going to go ahead and finish the sketch, do an extrusion, and if my math is correct and right, it should be 5.5625. Okay, now I can come up here and say, hey, I'd like for this to be wood birch. Okay, that's what dowel rod kind of looks like. And I'm going to go ahead and do a save. And I'm going to call this one my axle. All right, so I got that one saved. All right, so that is done. All right, so my follower rods, in this case, are going to be the square dowels. All right, so what that means for me is I'm going to have to come out here and create a new IPT. So I'm going to go out here, start a 2D sketch, go to my work plane I want to work on, use 2-point center this time, go to dimension, and we're going to make this 0.25. Okay, by 0.25, and we're going to go ahead and finish the sketch. Okay, we're going to go ahead and do an extrude, and I said last time those were 6 inches in length. Okay, we'll go ahead and just go with that, and we'll turn this to wood birch, just like so. I'm going to go ahead and do a save as. Okay, and this time, this is going to be my follower. Okay, so I have my follower rod saved. Okay, so if you kind of think about it, like I said before, we're going to have to make some sort of a bushing, all right? And we're going to call this the follower rod guide, all right? So I'm just going to show you real quick what that looks like. Where is my rod guide? There it is. All right, so here's something I just put together. Simple cylinder, okay? And we have this square on the inside. And if we take a look at this extrusion at the top, okay, we're going to be seeing that that square is 0.25 by 0.25, and that's cut all the way down through. The biggest thing we have to know is going to be what this diameter is. So if we take a look at this sketch, in this case, it's a 1/2 inch diameter. All right, I need to know what that is because I have to go out there and drill holes in the top part that are going to be this diameter, which is 0.5. All right, just wanted you to be able to see it. This is easily something that can be 3D printed. Okay, in this session, you're actually going to be getting these, or probably going to be getting these. Very simple part. You can 3D print. You can get a bunch of those. Okay, so I think we are basically ready. So let's go ahead, and this time I'm going to go ahead and just work directly through the IEM to make any changes I need to change. I'm going to start a 2D sketch. Actually, no. This time we're going to do something a little bit different. Last time I was creating a sketch, dropping that point in there, telling it where it needed to go, and then I went to the whole feature. But this time, let's just go directly through the whole feature. Okay, and I'm going to go out there and just pick on the surface of this, and I'm going to come out here and go to my reference edge. Now, last time, I do believe we made these 1 1/4 inches from the sides. So I have established that, and I'm going to come over here to this reference edge, and I'm going to say, hey, I want that to be 2 inches. All right, this case, I was just showing you that follower rod guide that is showing as a 1/2 inch diameter for that cylindrical base on it. So I'm going to say, hey, I want this to be 0.5, okay, and that's going to be a standard hole cut all the way through. I'm going to go ahead and say okay. I'm going to repeat the process again. I'm going to come out here, pick on the surface I want to go to, come to my first reference edge that is 2 inches away. My second reference edge is going to be this one, and that needs to be, what, 1.25 away. Okay, diameter 0.5, standard hole, cut all the way through, and I'm going to go ahead and say okay. All right, so I've now taken care of the holes for the top IPT. I'm going to go ahead and return back to my assembly. And now I need to go ahead and get my hole drilled in here for the 1/4 inch diameter axle. That's going to be running through this. So let's just go ahead and take care of that. So I'm going to double click on this side IPT. I'm going to go to my hole feature. Okay, I'm going to place that hole. I know my sides are 4x4, so I can go ahead and reference this edge. That needs to be 2 inches. I can reference this edge. That needs to be 2 inches. Okay, in this case, it's going to be a 1/4 inch diameter hole. Okay, standard hole, drill all the way through, and I say okay. I'm going to return back to the assembly. Nice thing is that since the side was a duplicate, any changes I make to one side IPT is going to be reflected on the other. All right, so just like with our basic assembly we did a little bit ago, now I can go ahead and begin dropping in parts I'm going to need. So I'm going to come out here and go to place, and I'm going to go out there and place, make sure I'm in the right place here. I had 2 different folders. All right, so there's my new axle. Okay, I'm going to go ahead and place that in. Okay, so we're only going to need one of those. And let's see, we need some follow rods. Let's go out there and place in our follower rods. Okay, there's my first one and my second one. So I got that taken care of. And I know I am going to need my follower rod guide. And that's what I was just showing you a little bit ago. These are just those bushings. Okay, and I know I'm going to need 2 shaft collars. And I was showing you those a little bit ago. And I know I'm also going to need my crank handle. All right, so everything's starting to be placed. All right, so simple enough. Let's get our axle in. So we come out here to constrain. We're going to come out here, use the mate type of constraint. We're going to use the mate solution, come out here and find the axis that rolls through that round dowel. And now we're going to go ahead and go to the inside of this hole, and we're going to find that connection between the 2 axes. Okay, when we do that, we're going to see that this thing is going to be able to slide through this, okay, going both ways. All right, now I need to add my shaft collar on this side. All right, so, well, let's flip it over this way. I'm right-handed, so I want to crank it with my right hand. Here we go. All right, so we're going to go ahead and say constrain, and now we're going to, in this case, let's switch it up. Let's go out here to insert constraint, all right? So we're going to say we'd like to insert, okay, this edge here and make contact with this edge here. If it does not look right, just know you have your solutions, okay? The first solution we are currently using is opposed, okay? If it doesn't look right, simply go to aligned and go ahead and hit apply. All right, now we're going to be seeing that those 2 are working just fine together. All right, now, the problem that we're going to have is that this is spinning independently from the axle. All right, so now this is going to take a little bit of work and turn on some work planes that we can use in order to constrain those. So I'm going to double click on the shaft collar. I'm going to come in here, go into my origin folder, and I'm going to find an axle, a shaft collar work plane that I can work with. In this case, this would work just fine for me. So I can go ahead and pick on visibility to turn that on and then return back to the assembly. I'm now going to go ahead and double click on the axle and come out here underneath the origin folder for the axle and find a plane that's going to be running long way down the axle. Okay, this one works just great. I'm going to go ahead and turn the visibility on and once again return back to the assembly. All right, so since I want these work planes to be working together, I'm going to come out and go to constrain. I'm going to be using either mate or flush. It does not matter. If I pick on one work plane and then the other, you're going to see how those align. I'm going to go ahead and hit apply and go ahead and cancel. Now when I spin this, you're going to see how those are now working together. All right, but the thing is I need for this guy to come all the way to this surface. So that's going to be using constrain and mate. I'm going to be picking the back face of our shaft collar and saying I want that to make contact with this surface here. I'm going to go ahead and hit apply and cancel. All right, so this guy is not able to move off of here, and it is able to spin, okay, on that axis. Okay, we're looking pretty good. All right, so I do want my shaft collar to come on over here. So I'm going to go ahead and do a constrain. I'm going to, this case, do an insert and say I want this face here, that edge, to be making contact with this edge, and I can see that that is correct. And I can even check the solution. Oh, that's not right at all, so I do want this to be opposed in this case. I'm going to go ahead and hit apply. Just like last time, we can see how the shaft collar is working independently from the axle. So in this case, constrain, we're now going to go ahead and do either a mate or a flush. It does not matter. Okay, go ahead and hit apply. All right, and now we're going to see that these are working together, okay, and spinning in the same direction together. All right, so I have my crank handle. He needs to come on, jump on this party. All right, before I do this, I do need a work plane that goes down through the center of this. So I'm going to double click on my crank handle. I'm going to come down, go to my origin folder, and I'm going to find a plane that goes right through it just like that. I'm going to go ahead and turn the visibility on and return back to the assembly. All right, now here's where I can come out and I can constrain this axis. So I'm using the mate constraint. It's going to be mate solution. Say I want that axis to be working along with this axis. I'm going to go ahead and hit apply. All right, so now I can see that this is working independently from the other one. All right, so I would like to come out and I can either go out here and do a mate or a flush. I'm going to say this plane and this plane. Okay, need to be working together. All right, I can see that those are now, okay, working together. All right, the problem is that this is sliding off, and my measurements are correct. I can already tell. All right, so if I come out here and do a flush between this face and this face, okay, now I can see that that is all one package, and that's going to work just great. All right, so I have my crank handle, my axle, everything is where it needs to be. It is able to rotate. We're doing pretty good. Okay, so I need my follow rods to go down through these holes, but before that happens, I need to install these rod guides. All right, so let's see how we're going to do that. Let's go out to constrain. Okay, we're going to be using the mate type of constraint with the mate solution. Come here to the outside of this rod guide. Okay, find that axis, and let's go ahead and pick to the inside of the hole. Okay, and yeah, that'll work just fine. Let's go ahead and hit apply and cancel out. The problem is that I want this guy to be down underneath. All right, so let's see if we can get this to work for us. It might get a little fussy. I'm going to go to constraint and say flush, and I want this face to be flush with this face. Okay, now that has gone on in. Now the problem is this is rotating. Okay, that is just fine. I'm going to show you something here in a little bit. We can get all those to align. That's just fine. Hey, for the second one, let's go ahead and let's try using insert. Let's go to constrain, let's go to insert, and we're going to say we want this to be inserted into here. And I don't like how that is looking, so if I just hit the second solution, which is aligned, and hit apply and OK, all right, this guy is going to do exactly what we just did last time. The nice thing is, the second time around, we actually cut out a step. All right. So we have those in. Now we need to go ahead and make sure that our follow rods are connected into those rod guides. So I'm going to go ahead and constrain this face to just one of these flat faces on the inside. Go ahead and hit apply. And since I have that one connected over on the other side, I'm going to flip this over if I can get to it. There we go. And I'm going to say I want that to mate to this face here. Go ahead and hit apply. All right, so that fits just perfectly in. You can see that this is also going to be able to rotate. Okay, still not a problem because we'll fix that in just a little bit. I'm going to do the same exact thing I did before. I'm going to go ahead and constrain one of these faces to the inside of one of these faces. Hit apply. I can go ahead and scoot this on over. Now I can go ahead and take a look at this, and I can constrain this face to this face. Go ahead and hit apply, and now this is going to be able to go up and down. All right, so now we are ready for cams. All right, so just know at this point in time, this is one of the sessions before parametric constraints and equations with cam design. You're not going to have these ready to go yet. You actually are not going to have these built. So just know right here where you're seeing the video, down below, you're going to see a folder where you can download, a button where you can download the files that you're about ready to see. In this case, the cams are going to look a little bit different than last time. Okay, remember the axle that we have is round, it is not square. All right, so I'm going to go out here and place we're going to use the centric cam just like last time. And we're going to also place, let's do a pair cam this time. Actually, I think it was a pair cam last time too, that's okay. All right, so let's go ahead now and let's constrain the axis of our arbor hole of our cam to the axis of our axle. Let's go ahead and hit apply, and we're going to see that this is able to slide back and forth. Okay, so when the cams are created, and if you do this properly, we're going to see a work plane is going right down the center of that. Okay, and how easy would it be just to come back to our follower rod, double click on it, and say, hey, Mr. Follower Rod, let me see your origin folder, and let's find a plane that's rolling right down the center of that. I'm going to go ahead and turn that on. Okay, I'm going to go ahead and hit return. All right, now, depending on how you put the other one in, okay, that other plane, could be it could be going the other way. So just know, you don't have to delete that and start all over again. You could come down here, go into your origin folder, okay, and you could turn on both of these at the same time. Okay, just like so. So it is going to be sort of a cross area. It can get a little jumbled up with work planes. Just know you can turn those on and off just by going into the IPT. Okay, so now we are set and ready to go. Now watch how this works. We're going to go to Constraint and go to Flush, and I'm going to say I want this work plane to be flushed with this work plane. I'm going to go ahead and hit Apply and cancel out of it. We take a look at the front of this, and we can see that cam is not able to move back and forth. Okay, and when we did that, here's kind of the cool thing, is that we have now fully constrained, okay, this rod guide. All right, pretty cool, right? All right, let's do the same thing for the other one. Okay, let's go out there and go to Constraint, and let's go ahead and mate this axis, okay, to this axis. Looking good. Okay, we're going to go ahead and hit Apply and Cancel. And now we're going to go ahead and we're going to do a flush between this work plane and this work plane. I'm going to go ahead and hit Apply and Cancel. All right, once again, we're going to look at this face. Okay, and we can see that that guy is not able to slide down the axle. And when we do that, okay, we have the magic happening here with the rod guide. It's not able to spin anymore. All right, so I'm going to go ahead and just pull this down a little bit. All right, so in this case, you're going to need some sort of follower rod base, all right? And if you watched the last video from the basic one, things got a little bit goofy when it came to that. So this time, I'm going to go ahead and just take a look at this. I'm going to let you see what I've done with this. So let's see, what did I call it? Oh, rod follower, there we go. So this is what the rod follower looks like this time. All right, on the bottom of this, you're going to see how I have included that arc that has been extruded. It's a symmetrical extrusion. Okay, in reality, are you really going to need this when you go to do the actual build, the physical prototyping? No. However, when it comes to Inventor, it can get a little bit fussy when it comes to transitional constraints, so you are going to need this. All right, so just wanted you to see this. Okay, pretty simple stuff. All right, so I'm going to go ahead and close out at IPT. Just want you to see it, and I'm going to go ahead and place that rod follower. I'm going to need 2 of those. I'm going to say OK. And now it looks like they're coming in a little bit goofy, so I'm going to go to free rotate, and I can pick that guy. And let's just see if I can do a little free orbit and constrained orbit within that globe. Kind of nudge it in the right direction. There we go. Looks good. Okay, same thing here. Free rotate. Grab that part, use free orbit, sort of nudge that in the right direction, maybe with a constrained orbit at the end. All right, cool. All right, so what we have to do is go ahead and get that onto the bottom of the follow rod. Remember, this is not reality. We can do things like pull the follow rod all the way up, and we can go ahead and constrain this guy first, and then we can slide it through, and it will kind of ghost through that wall. All right, so let's go ahead, let's constrain it. So the first thing is I'm going to come out here and say mate the bottom of that face, okay, with the bottom of my follower rod. Go ahead and hit apply. Okay, and now I can go ahead and constrain this face to this face. Hit apply, and I can constrain this face to this face and hit apply. All right, so kind of looks like Cupid's arrow. All right, this guy is fully constrained, not rotating, nothing silly. Now check this out. We can push that through, make that ghost all the way through, comes through to the bottom of that face, and now he's sitting right on top of that cam. Pretty cool, right? All right, so we're going to repeat the same process. I'm going to pull the follower rod out, give myself some room, okay, and now I can go ahead and begin constraining this base. I'm going to go to the bottom of that face, to the bottom face here. Go ahead and hit apply. Okay, and now I'm going to go ahead and mate that face with this face. and hit apply. Remember, if you need some more room, you can always pull it out. Okay, constraint again. I'm going to mate this face, okay, with this face and hit apply. All right, so this is all going to be working together as a team. Okay, and we can go ahead and just shove that down through that face, flip it around to the back side of it, and now we can see that that is right on top of our cam. All right, so since we're all in a twisted mess here, let's just go ahead and go to home view, pull this back, okay, and now is where our transitional constraints are going to have to come in. We're going to go to constraint, go to transitional constraints. We're going to pick the bottom, okay, of that base first, and we're going to say, hey, we want there to be a transitional constraint between that face and this face here. Go ahead and hit apply, and we can cancel out. All right, so one last one. Okay, we have our pair cam. We're going to go to transitional constraint and say I want this face to be making contact with this face. We can go ahead and hit apply. All right, let's see how our transitional constraints did this time. Okay, when I come out here, oh, I forgot to do one thing. Oops. All right, let's do one more or two sets of constraints, and let's get these pairs or these cams where they need to be. I'm going to go to constraint, go to flush constraint between this work plane and this work plane, hit apply, and I'm also going to come out here, and it looks like I'm missing a work plane. So I'm going to go into my IPT, and I'm going to turn that work plane on. There we go. Let's turn that guy on. Let's return back to our assembly. All right, here we go. So now we can come out here and take a look. Okay, we can see that that face is blue, that face is blue. I'm going to say I want this face to be flush to this face. Here we go. Let's apply that. Now let's cancel out, and now let's try our crank handle. Hey, it looks pretty good. Working really good. Okay, so transitional constraints are working. Okay, so just sort of the icing on the cake is we need one more peg. Go ahead and drop in for our crank handle. That can just be a quick IPT creation. Okay, and if I remember right, I believe that hole that's in that crank handle is the same as the dowel for our axle, so we can dimension that. And that needs to be 0.25. A matter of finishing the sketch, doing an extrusion. And I don't know, I'm just going to give myself, yeah, I think an inch will be fine. Maybe an inch and a quarter. Say OK, go up here, turn this into wood birch. Do a save as. Okay, and now this is going to be our crank handle, and we're going to call this our crank handle peg. We're going to do a save. All right, so we can close out at IPT now that that is created. Now we can go out there and place our crank handle peg. Drop that into our assembly, and this time let's go out there and constrain that using the insert constraint, saying this edge needs to be lined up to this edge. That's the wrong solution. Flip it around, say OK, apply and cancel, and we are good to go. All right, so there you go. So this is a little bit more advanced than what we were seeing earlier. But what is kind of cool with this is now we don't have to worry about our follow rods spinning, unless you want them to spin, of course, in which you can offset the cam on that. There you go. I mean, we've got some 3D printed parts, maybe some laser cut parts. But there you go. This might be looking a little bit more of what we're actually using in our actual session, some of the parts we're handing out. So main reason on this one is we're just getting rid of that big obnoxious square dowel for the axle and replacing that with a 1/4 inch round dowel, and it's going to be much, much smoother.